Steganalysis is the process of detecting steganography and recovering hidden evidence. However, this is a very difficult task. Whetstone, as shown here, is one of the leading companies for malware detection and steganography detection. They have a suite of tools for steganography analysis, including Stegahunter, which is a utility to search for any Stego tools installed on suspect's machine. If such tool is identified, it indicates that the suspect has the capability, has the ability to use steganography to hide data. For example, if JP hide-and-seek is detected, the investigator should especially pay attention to JPEG images because those images may contain hidden data. Stego Suite includes 3 software tools: Stego Watch, Stego Analyst, and Stego Break. Certainly, Stego Watch is used for detection, and Stego Analyst is for analyze, and then Stego Break is for breaking the password to recover hidden evidence. Stego Suite is a commercial product. I have one license, but this license has been many years old, so their new products may have a different look and different features, but I just want to show you some basic ideas how those detection and then analysis tool looks like. All right, so I have here Stego Watch. Let me open that. Now, first thing you need to do is to set up the directory, the starting place for Stego Watch to search through. So I specify here is the Stego demo data. I will show you later. So that is a starting directory. Then Stego Watch will go through this directory and including his subdirectories to identify all images, and then compare those images with the normal mathematical and statistical models, try to detect whether it has any information hide inside of those images. So once I choose that, then you have a location to search, then you just simply say start new session. All right, it will go through it very quick, so that's very impressive. And then very quickly, and it gives you its guess based on their model, their algorithm. So the directory here, this is the directory I wanted to search through. All right, so here are the covered files, images in the directory, and then you probably still remember this invisible. This is from the invisible secret, using invisible secret, and then the hidden mom and this hidden. Those two I gathered from using stools, and I use the JP hide-and-seek to hide information into this water lily picture. Now I also have a clean that folder. Those images are clean, supposed to be clean. One is a penguin, one is that mom, and I got those from basically Windows, just from Windows sample. And then the JPEG, I have a couple of that JPEG files. Those two are also from Windows sample file, and this is from my own picture. I took a picture. I live in a beautiful northeast. It's in Rochester, New York, and that's the picture I have. So this is the directory I searched through. Okay, so now it says this hidden.gif file. This one is has a highly risk to be to have a hidden data, and then A is it identifies artifacts, and the N means medium risk to have a hidden data, and the low has a low risk, and the OK, that means it's clean. All right, so let's launch another tool. You can launch it separately like a Steganalysis, or you can launch it from here to really look through it. Because detecting is difficult, so there are false positive and false negatives. We were going through the analytics to look through those high risk or medium risk or low risk files, try to find. Now, first, let me go through here the covert, and again, this water lily picture has hidden. I use a JP hide and seek to hide information into it. And what information I hide into that? Actually, I hide a very, very small text. So this is what I hide. It's tiny bit, so it modified only a little bit. Now we want to see modify that little bit, and let me compare this with the original one. So the original one is in the JPEG clean version, water lily. Okay, so those are two. Okay, this one is from original, and then this one is JP hide and seek. So the name, you can see the names here, and here is the pass. Now hash is different. Okay, this is the first alert. If you see two images almost identical but hash different, that means something changed. And file size normally the hidden ones, because of compression, is smaller. Okay, sometimes can be same. Okay, especially use S tools. If you use S tools, then sometimes it's the same size. But for JP hide and seek, most cases it is smaller, the hidden one, because it's going through encryption and compression. Now, certain artifacts we can look into that. Because for JP hide and seek, they hide the information into the DCT coefficient. So we can look at the DCT coefficient. Now for this case, because I'm only hide tiny bit information, so shouldn't change that much. But if you look at that, the sharp ones usually is the normal one. It looks like pretty similar. But if you look at the scale, this is a 500. It's down a little bit, and this is a little bit more sharp. Okay, so cannot absolutely say that, but with your experience, and this might be malicious. This might be okay. So this is one is look at the DCT coefficient, and use the color. And normally the one with artifacts, that one uses more color. That's normally the case. Okay. And then what other information? Now the header, the JPEG header. This is the special artifacts for JP hide and seek. Using JP hide and seek, it will scratch the header. So the header information is gone, and this information is still here. So this is the normal one, the original one, and this is the after using JP hide and seek, hiding information into that, this title is gone. So this is for specific JP hide and seek software. So that's the case. If the suspect did not modify anything, just use it, then that one looks like is malicious. The other things you can look into that is transform, intensity, saturation, and hues. Now in this case, it may not be able to see much because we only modified the tiny, and I use my eyes cannot detect much of anything. But let's just looking through it. The saturation, and let's see whether this has any difference or not. Hue. Now hue is basically if the resolution change and then the snowy color. Now again, because we only insert a tiny bit of information, you don't see. For the other ones, this is a great feature. If you look at the hue, the one with snowy, that image most likely has data hidden into it. Okay, so those are the two images we are looking at. Now, if you look at the Stego watch detection result, okay, one is water lily and one is JP hide and seek. So here it says JP high-seq, it's a median risk, and then the water lily has a low risk. Okay, it didn't say clean. I don't know, some kind of noise is in there. So this is pretty good at this point. And then let's look at, can we look at them one more? Look at the GIF file. So first, let's open up one from the covert. So this is the penguins, and in the covert message, and then here let me pick up the clean one. Now those are the GIF file. So for GIF file especially, you need to look into, okay, let's first look at the details. Again, looks very similar image, and then the hash is different, the size is different. All right, again, the size is smaller. So this is the one actually has hidden information inside. Now, because those are the palette, those are GIF file, those are the palette, and the total has 256 colors. Now, how many colors this used? This used 252 color, and this used 256. Used the color, yeah, this is 256 and 252. And we talk about similar colors, close colors. That's an indication, okay? So the close color, because they are using pairs, okay? The close color, if you use a lot of more close colors, very likely that may have hidden information. But those are all basically just guess, all right? So then now if you look at those two images, again, you can use the intensity, saturation, and the hue to identify that. Okay, look back to our image result, the stagger watch result. This penguin, one is called the penguins.gif, and so one is called penguins.gif, and another one is called a hidden. So the penguin.gif and then the hidden.gif. Now in this case, certainly the hidden.gif, it says highly risk with artifacts, but this penguin.gif, it also says it's a highly. At this point, I really don't know, because this is the Windows image, right? I'm not sure whether this is really has other hidden data or not, because I'm just using the sample image, and then I hide additional data into it to get a hidden.gif file. All right, so now how about the invisible? Okay, the invisible secret we did from last video. That one, unfortunately, it is not able to detect. It's just question mark. It's some version unmatchedness and all. It is not able to do it. So nevertheless, actually, this detection do give us some picture of how to which file should be pay attention to or not. And then I also showed you some of the artifacts we can use to when we do analysis.